So let's look at a couple examples here of how we can find missing sides and angles in a right triangle. All right, so we have a right triangle. That's important. We got one angle. It says this is in degrees here. And we need to find some missing parts. Okay, so we need to find an angle here. Let's call this, let's go with the Greek letter alpha. How about that? So we need to find alpha there. And we know that the angles in a triangle add up to 180. So since this is a right triangle, if you take 180 minus 90, you get 90. So it's useful to know that the two acute angles, the two angles that are smaller than 90, add up to 90. So we know that alpha plus 75 equals 90 degrees. So subtract 90 degrees there, and alpha, or angle A, is going to be 15 degrees. All right. So our goal is to find all the angles and all the sides here. Got it? There we go. And so let's call this an X and call this a Y. Now, we can use either angle. It doesn't matter. We know that's 75. We know that's 15. They're both acute angles. Doesn't matter. Well, let's go ahead and maybe use this 15. Why not? So 15, let's find X. How does X relate to this angle? Well, X is opposite. So we have the opposite is what we're looking for. And what do we know? We know the hypotenuse. So we ask ourselves, is that sine, cosine, or tangent? Well, that's sine. So the sine of angle A is equal to opposite over the hypotenuse. And so, well, our angle is 15 degrees, and that's opposite, which we don't know, X over 15. Nope, sorry, 12. Let's make that 12. 12 is the hypotenuse. Opposite over hypotenuse. Okay. Now, I'm going to show you another little shortcut here, all right? We can go to our calculator and find the sine of 15, plug that in your calculator. And I'll use Desmos again because it works nice on the iPad here. Okay, you got to make sure you're in degrees. So, by the way, the graphing calculator is in radians to start. So, I got to change that to degrees if you're going to use that. So, we wanted the sine of 15. Sine of 15. 0.2258. Write down 4 decimal places. 2258. So, two ways to do this. One is like we did before, 2258 equals X over 12. Okay. And now, this one's kind of nice because the variable's on top. So you could think about cross multiplying if you want. You can think of it that way. Or we just need to get this 12 out of there. So really all we need to do is just multiply both sides by 12, the denominator, to get that out of there. All right? So we have X equals 12 times that number. Okay, so we can come back over here and say, well, let's just take that number and multiply it by 12. So we can go 12 times 0.2588, and there's our answer. Now, really all we're doing is we're taking 12 times the sine of 15, right? So once you get okay with the fact that sine of 15 is just a decimal number, it's just point blah, 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 whatever, then you really don't need to go find that. All we need to do is say, all right, the sine of 15 is some weird decimal number. I'm not sure what it is, but I know that I'm going to take 12 and multiply it because I need to cancel that out, and that will leave me with X on that right side, and whatever 12 times the sine of 15 is. So we can go to our calculator here, and we can say, all right, well, what is 12 times the sine of 15? And there is a better answer. Notice this rounds to this, but this is even more exact. So we never really needed to find this 2588. So we can just say goodbye to that. So once you get used to this, and once you realize, you know what, the sine of 15 is just a decimal number, then just roll with it, okay? And so anyways, we got 3.106, okay? I don't think the instructions here told us exactly what to round to. So we'll just leave it at that. That's good. What about y? Well, y is the adjacent. It's connected to or next to the angle. So we have adjacent and hypotenuse. So which ratio uses adjacent and hypotenuse? Well, that is cosine. Cosine of our angle is adjacent over hypotenuse. All right, well, what is our angle? The angle that we're using is 15. We could use a 75 if we wanted, but it would be it wouldn't be cosine, it would be sine. So that's y over the hypotenuse, which I keep messing that up. That's 12. All right, so let's use that, our new shortcut. Cosine of 15 is some weird decimal. I don't really want to go figure it out right now, and I don't need to. All I need to do is I need to get rid of this 12, so I'm going to multiply both sides by 12. I'm going to do 12 times this. And so to find y, all I need is 12 times the cosine of 15. All right? So we come back to our handy-dandy calculator, and we say, what's 12 times the cosine? Oh, nope, not cosecant. 12 times the cosine of 15 degrees. Again, we're in degrees, not radians. And we got 11.591. 11.59 is probably good, but why not be a little more accurate? Okay, there you have it. So let's go look at one more application problem here. So we have a couple planes, one traveling due west, and the other's going 25 degrees north of west. So let's draw a little picture here. One's traveling due west, and one is going 25 degrees north of west. Okay, so 25 degrees. After 2 hours, the first plane had traveled 1,000 miles, and the second plane was exactly north of the first plane. All right, so we were going to make them, let's clean these arrows up a little bit here, these lines. Okay, and let's make them so that one is directly north of the other one. All right, so this guy's going over here. There we go. All right. So third due north. So that gives us a 90-degree angle there. Okay. And we know that the first plane that was going due west had traveled 1,000 miles. Okay. So the question is, next, how far did the second plane travel to the nearest hundredth of a mile? Okay, so how long is this distance? Let's call this D. Well, let's look at our situation here. We've got the adjacent, and we're looking for the hypotenuse. So which one is adjacent to the hypotenuse? That is cosine. So cosine of our angle, 25 degrees, is the adjacent 1,000 over the hypotenuse. And we need to solve this up. Well, here we have this situation where the variable's on the bottom, so we're going to need to cross multiply or make a proportion out of this. Or we can use the swap property. So we know this. We know that the cosine 25 is just a decimal number. So we don't necessarily need to go find that right now. Just leave it alone. Cosine of 25, point something, something, something. But we can swap those in a proportion. Remember we saw that a few minutes ago? And so we got 1,000 divided by cosine 25. So whenever the variable is on the bottom, you can swap like that. We can go to our calculator and find out what that is. And that comes out to be about 1,008 miles, 0.87. What did it say? Nearest hundredth of a mile. That's 2 decimal places. So it's 875, so it's 88 miles. All right. And last but not least, what's the average speed? Well, this is for 2 hours. So plane number 1 had a speed of 1,000 divided by 2, and that's miles per hour. And so that's 500 miles per hour. And plane number 2 was at 1008.88. And that is miles for 2 hours. And so this one's going 504.4 miles per hour. All right. So, well, anyways, there's a situation. So when we have an application, we want to draw a picture and write the trig equation and answer the question. Plug in what you know, solve for what you don't. That's the basic idea. Hope that helps.